Okay, Assalamualaikum. My name is Fikri Ben Rizal. So you can call me Fikri. So I will start to my presentation for the lab 4 in activity 1. So I got the circuit. So I will use multi-sim for perform this circuit. Um, okay, this is the simulation circuit for the activity 1. After we perform this circuit, we need to set the value of Vs, which the same as same as in the table. For Vs is 10 until the 100 volt. So first we try to set the voltage for 10 volt in the multisim. So far we set the 10 volt in the AC power. Then okay, after that we start to running the circuit, and after we got the result, for the wattmeter we got 2.47 watt, and for the voltage resistor we got 9.0, and for the voltage inductor we got 4.3 volt. And after that we got the current of this circuit is 0.27 ampere. So after we got the result value, we insert the result into the table. So like this, we insert, and after we done, we continue the simulation for the for the uh, 20 volt until the 100 volt, and we fill the result in the table. So what I find in this experiment, we we know that the result is when the Vs is increased from the 10 until the 100, the value of the value of current, voltage resistor, voltage inductance, and power will increase too, like this. And then after that, we move to the next circuit on the table 4.2. So in the circuit is like this. The difference of the circuit is the circuit one is series, and the resistor is series, and the second circuit, the resistor is used in parallel. So that we move to multisim to perform the circuit. Okay. This is circuit for the activity 1 in circuit 2. So this is resistor that have been installed with parallel circuit. So that we use the voltage same like the table 4.1. We start from 10 volt. Um, change the value as 10, and then after that we run. Start run, and we got the result. Same like previous experiment, we insert the result into the into the table, and after we done insert the value, all of value, um the experiment show that same like table 4.1. When the Vs value is increased, the value of current, voltage resistor, voltage inductance, and power will increase too. But the difference of the value which table 4.1 and table 4.2 is a little bit different about the value. So, example, in the power of voltage PS410, the power is 2.47 in the table for 4.1, but in the table 4.2, the 10 voltage 10 volt is 2.445. So they a little bit different, but we can assume it is same value. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Akmal bin Mak Najib, Kat Matrik DE220145. Untuk kali ini saya akan membentangkan bahagian saya untuk lab series L dan RC circuit. Okay, terlebih dahulu saya merupakan daripada grup 2, section 2. Okay, nama syarah saya Dr. Khairul Anwar bin Muhammad. Jadi untuk bahagian saya telah mengambil bahagian aktiviti 2, iaitu untuk steady state behavior of RC series circuit. Okay, jadi untuk aktiviti kali ini dia ada 2 gambar rajah, jadi saya perlu buat 2 simulasi. Jadi untuk simulasi pertama iaitu litar tersiri, dan untuk simulasi kedua iaitu litar selari. Jadi untuk litar tersiri, jadi nilai yang telah ditetapkan telah saya ambil. Jadi ini adalah simulasi. Jadi untuk simulasi ini saya telah menggunakan wattmeter, multimeter, kapasitor, resistor dan sebagainya. Jadi untuk pertama kali, nilai yang pertama iaitu nilai yang perlu saya ambil ialah nilai RMS. Jadi yang kedua iaitu nilai yang berada dekat wattmeter. Yang ketiga iaitu nilai yang berada dekat di resistor pertama, nilai voltage. Dan yang ketiga ialah nilai yang berada di kapasitor, nilai voltage. Jadi setelah saya buat, jadi saya perlu menukarkan nilai voltage sesuai dengan tabel ini. Jadi nilai voltage ini saya ubah mengikut kehendak lab. Jadi ini adalah result untuk gambar rajah pertama. Okay. Jadi untuk gambar rajah kedua, yang ini, kapasitor berada selari dengan antara masing-masing. Jadi nilai power supply pun saya ubah mengikut kehendak lab sheet. Jadi nilai yang perlu saya ambil ialah yang pertama dekat IRMS, nilai yang berada dekat resistor, nilai voltage. Seterusnya nilai yang berada di ketiga-tiga kapasitor, nilai voltage-nya. Okay, kemudian saya catat result dia mengikut tabel. Jadi nilai untuk resistor untuk gambar rajah kedua iaitu 50, berbeza dengan yang gambar rajah pertama. Okay, jadi apa yang dapat saya simpulkan ialah semakin bertambah voltage, jadi semakin bertambahlah current, iaitu arus yang berada dalam sesuatu litar itu. Jadi untuk lab kali ini ianya seragam, ianya sesuai dengan Ohm's law, iaitu V equal to IR, di mana resistan dengan temperature itu kita tetapkan nilainya. Jadi nilai voltage ataupun nilai current yang kita ukur tu, salah satu tu akan jadi bertambah seiring dengan nilai yang kita mahukan. Itu saja daripada saya. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim Daniel bin Muhammad Azhar. My number metric is DE220189. So today I will present our group to talk about activity 3 that our group already done together. So this is the question from the lab sheet. Show the activity 3. And inside the activity 3, it has two questions, which is one for the table 4.1 and 4.2, and second question is table 4.3 and 4.4. So without further more, I will go through about the first question, which is I need to plot the graph of VR versus VL versus I, and V versus VI curve. I need to plot the graph based on the table 4.1 and 4.2. So we go to the Excel. The reason I show the Excel is our group uses Excel to find the graph because it's much easier to find the graph using Excel, using the data that we collected from the table and also from the circuit simulation. So from here, this is table for 4.1. The first question, we need to find the VR versus I. So here, we just copy the I column and VR column, both of them, and then we go to the insert and go to the line graph, and then we get the graph like this. It will show the Excel will show the graph VR versus I like this. It shows that the greater the VR, the greater the I. For the next question is we need to plot the graph VL versus I. So here I use the same method, which is I copy the VL column, paste in here, and also the I column, paste beside the VL column. So from here I use the same method, I copy both of them, both of the column, and then use the same method, insert, go to the line graph, and then I get this graph VL versus I. This graph show that the greater the VL, the greater the I. So for the next question is I need to find the power versus VI. To find the VI, we need to use the VS multiple by I. So here, as you can see here, this is the table that I'm using. I copy the VS column and also the I column, paste beside each other, and then I multiply VS and I and get this column, which is the VI. This is the value that I get from the multiplication of V and I. So beside the VI column is a power column, which is I just copy from the table 4.1. So I use the same method, I copy VI and power, all of the column, and use the same method, the Excel show the graph power versus VI. From here, from the graph, we can read that we can see that the greater the power, the greater the VI. So for the next question is I need to inside the same question, I need to use the 4.2 table. So we go to the 4.2 table. This is the 4.2 table. So the 4.2 is inside the same question, which is VR versus I. So from here, we use the same method, VR versus I, and then we get the graph, which is the graph will be shown like this. VR versus I is when you can see that the greater the VR, the greater the I. So the next question is I need to plot the graph VR versus I. So here is same method, I copy both of them and paste beside each other, and then go to the insert, to the line graph, and I get this graph, which is the graph of VR versus I. As you can see here, the greater the VR, the greater the I, based on the data collected from the simulation that our members already done. So the last question is I need to find the power versus VI. The same, which is VI, we use the VS and I, which is multiple VS and I, and get the value, which is like this. This is the value from the multiplication of V and I. Beside the VI column is the power column, which is I just copy from the table 4.2 and paste it beside the VI column. So from here, I use the same method, I copy both of the column, and we find the graph, which is show that the greater the power, the greater the VI for 4.2 table. So for the next question is draw to scale the phasor diagram for the circuit based on the voltage readings obtained when I equal to 1 ampere. So from here, we were using the formula given inside the lab sheet, and we get the calculation, and our group can draw the phasor diagram. This is our calculation, which is
Hi, my name is Muhammad Abdullah Awad. I'm a matter of SB 190015. I am Group 2, Section 2. I would like here to present my part of group assignment discussion 51. As you see, this picture shows after running the circuit figure 4.5, this is figure 4.5, TSM software, running as TSM software, for the resistor value 33 ohm, then stored in series, and the electric values 50. Then VS value that we have is set from 10 volt to 100 volt. take regard from the emitter voltmeter and wattmeter and insert the result measurement in table 4.1 as you see there before. Uh, and also activity 2. In activity 2, after simulate and connect circuit figure 4.7, 4.7, multisim where the resistor value 100 ohm, capacitor is 28. It's connected in series with AC supply 200 volt and 50 X. The VS value that we set in from 10 unit till 1000. For the activity 3, an activity 3 from the data that will be collected from the simulation circuit 4.5, 4.6, 4.7, 4.8, multisim will insert the data inside table 4.1, 4.2, 4.3, and 4.4, which we need to find value of I, VL, VC, VR, and power watts. By transferring the data into Excel from the table 4.1, we create a graph of VRs. Also for the data in table 4.2, we transfer the data and insert it inside Excel. And also for table 4.3 and 4.4, we also the same methodology transfer the data into Excel. For the equation 1B and 2B, we are using the formula given inside the lab sheet to calculate series RL and RC circuit. To draw the phasor diagram calculation is already calculated both equations. We can draw the phasor diagram and find P equal IS IZ with the angle using formula RL and RC circuit. Thank you. For the calculation, we have learned a lot about the behavior of RL and RC circuit through the lab activity on series RL and RC circuit. Several inferences regarding the behavior of the circuit. We are maybe examining how the circuit reacts to various input signals. When a step voltage is supplied to RL circuit, we notice that current flowing through the circuit steadily increase and takes some time to reach this steady state value. Additionally, we noted direct correlation between the circuit inductance and time constant. On the other hand, we found the RC circuit when step voltage is supplied, the step voltage grows gradually and takes some time to reach this steady state value. Additionally, we note direct correlation between circuit capacitance and time constant.